What we have to do today is we look at the JDBC. So we are going to learn how to access the database via JDBC. And this is important to you because it's going to be one part of your assessment, which we're going to do. So you need to learn to write simple Java JDBC SQL applications. So we're going to write an application in Java which interacts with the database, gets information out of it, displays it to the user in some way, maybe updates the information, etc. Now, the book that you're normally reading doesn't really cover this particularly well. There is a book called Java and JDBC. The RIS book covers what we're going to do better. I wouldn't buy it just for this, but you can borrow it from the library if you need to have additional information. And there are other things there. There might also be online help that you find. So you have things like the JDBC specification that you can find online. You have things like the JDBC tutorial, which you can find online. I think some of these might be on your reading folder as well for the module. And you have the Java JDK documentation. So all of those things will be additional sources of information if you're stuck with what you want to do. And the PostgreSQL documentation on JDBC. So all of those things are additional sources of information for when you start doing that, so that you can find, if you're stuck, all the information that we need. Because we are only going to do one lecture, so we only have a little time for this. After that, you need to really get on with it yourselves. So we're looking at JDBC, which is an API package. And there are many versions that have been updated. So it started being version 1, then there was a 2, a 3, and even a 4. Now, the kind of functionality that we're going to use is the very basic functionality. So it was provided by the first package, by JDBC 1, and it has been improved ever since. But we're not going to look at the more complex aspects of JDBC. So what we are going to look at is fairly simple JDBC, and it was covered even by the first release. This JDBC fits well with other Java packages, which are widely available, and is similar to a C interface to ODBC function library. So there are other ways also of accessing a database, such as SQLJ. This is preprocessed Java and embedded SQL arrangements. Sometimes it makes for more efficient runtime programs, but it's less commonly implemented. So we're not going to use it, but you should know that it exists. There are also things like enterprise Java beans that try to hide the details of persistency, so you can write kind of like code and make it persistent to that. We're not going to look at that either. And there are also web scripting languages like JSP, Java-like scripting languages. Again, this is not part of what we are going to cover. We concentrate on the JDBC package. So when we look at the JDBC package, what we have is we write the Java program, and that program is going to use this java.sql interface to communicate with the database. It could communicate with an Access database, it could communicate with a Postgres database, it could communicate with a DB2 database. The program can communicate with different types of database management systems. What we need is a driver that is specific to the system that we are trying to communicate with. So in our case, we will need the JDBC for Postgres SQL driver, which is going to allow us to communicate with the Postgres SQL database. If we wanted to communicate with the Access database, then we will use a driver for that, which might establish a JDBC or DBC bridge, and so on. And we could do it for other type of database management systems as well. So we concentrate on this JDBC interface, and there are a number of methods that we need to learn about. So we have a driver manager, and that is going to register a number of drivers. In this case, we're going to register the driver for the Postgres SQL database management system. Once we have registered that driver, we can communicate with the Postgres SQL database. And the first thing that we have to do, as you do when you use a database, is establish a connection to it. If you don't have a connection to the database, you cannot do anything on it. So as when you go to to use it interactively, you need to establish a connection, establish what is your username, your password. Once you have a connection, you begin to be able to interact with the database. Through the program, we have to do the same. So there is a method that allows us to establish this connection. And we have to use it. Once we have established a connection with the database, we can then use methods to send the statements to the database for execution. And that is going to be either a normal SQL statement, or a prepared statement, or a callable statement, which we will look at towards the end of the lecture. And we are going to be able to get a set of results. And what we have to do in the Java program is manage the results. The difference between Java and SQL is Java handles one thing at a time, one row at a time. SQL returns a set of rows at a time. So we have to have some method of scrolling through a set of results that are returned from SQL so that we can do whatever we want with them in the Java program. So that is that part of the methods that are going to allow us to define a result set, which will have associated metadata. So we can access the metadata for the result set. We can also access the metadata for the database that we are trying to connect to. So we will see how we do that through Java. Access the database metadata or access the result set metadata. Both of those things are possible. So we're going to look at how this works by writing programs that use these methods. So the connection methods, which are the ones that we use first, the ones that allow us to establish a connection to the database, are things like get connection, which is going to allow us to have a driver manager. Once we have a connection established, we can create the statements, we can commit, we can roll back, we could set auto-commit on or off. So if we work with a database management system that uses auto-commit on, we could turn it off and take control of transactions. We can close resources. So if we open a connection, we need to at some point close that connection. If you open a connection and you leave it open, and then some other student does the same and some other student does the same, you'll end up basically killing the system because there will be too many connections open. So I will show you how to always include code that no matter what will close the connection and will close the resources that you have open. Otherwise, by the time you all get doing your coursework, opening things that you don't close, the system will kill over because it's not that powerful a server to handle a lot of open connections left. So it's important that you release the resources that you use. Once we have a statement, we can do things like execute query and execute update, which are going to handle different types of SQL statements. Again, for a statement, we want to release the resources allocated to that statement when we finish with it. So we're going to close it. And when we have a result set, which returns from a query, we can navigate through it by using the next, which is going to move us to the next row of the result set. And then we have a series of get methods, which allow us to get whatever is in the results that are being given to us. So we could get a string, get integer, get all the different types to actually access the result set data and put it in a variable that we're then going to display in the program. And we also have, as I said, access to the database metadata and the result set metadata. So we have get table methods that allow us to access that. So let's look at our very first JDBC program, which is a very simple program. In this case, it is going to access a database, so it's going to load the driver. This is the first thing that we always have to do. And we only need to do this once. And then we close the connection at the end. So the connection, we only need to establish once. I've seen the students that every time they execute a statement, they open the connection, they close the connection. You don't need to do that. You open the connection at the beginning of the program, you close the connection when you're exiting the program. You don't open and close for every interaction, because that makes it less efficient. So we connect to the PostgreSQL database, and we are going to select a single value. So it's going to be a single column and a single tuple. So the only thing that we have to handle back is a single value that is going to be returned in this very simple program. We will tidy up, and we will do very minimal error handling. So the code for that is there, but we're going to look at it one stage at a time, which is we need to look at the whole of the program. So that bit of code there does everything, from establishing the connection to establishing an SQL statement, etc., etc. And then at the end, does some small amount of error handling, and then this is the bit that actually releases all the resources should you have left anything open, so that you can tidy up at the end. So we're going to go through this one stage at a time, but this is what the program looks like. So the first thing that we have to do when we are going to use JDBC is to load the driver that we need. And in our case, it's going to be the Postgres SQL driver, because we need to connect to a Postgres SQL database. So one of the first things that we're going to have in our program is this statement that says class for name, and then in inverted quotes, the name of the driver that we are going to load. Once we have declared the driver, our program can then access the JDBC Postgres SQL database in order to execute the statements against it. So we must have that for every program that we write, which needs to access a Postgres SQL database. And we only need to do that once. Once we have declared the driver in the program, then the program knows that this is the driver it's going to use. Once we have done that, I thought I had changed everyone, but not yet. We're not going to connect to DB2, we're going to connect in our case to Postgres SQL. We used to do DB2, but now we do Postgres SQL. For this, we have to give the ID, the user ID, and the password. We had problems in the past when people used to put their name and password in their coursework, and then they would leave it lying around, and everybody could then find it, log into your email, look at your secrets and your life. So we no longer want you to do that, because this is not what we want. So we will give you a little program that you will have to load, which is going to hide the detail of your password, or ask for it as you begin to do the program, so you never have to put it in your code, so that if you print your code and leave it in the lab, it doesn't get left there. So that will be dealt with by a little program. But generally speaking, when we want to establish a connection, we need to be given three things. One is, what is the URL of the connection? And in this case, you have to check this in the labs, because I was trying to remember yesterday, they changed the name of the server from year to year. I think that is the new name, but it might be slightly different. If not, the people in the lab will tell you what it is for this year. But this basically just says, establish a connection to the 2B08 database, the one that you've been using in the labs. So all that you're doing there is giving the address of that particular server, which is going to allow you to establish a connection to this database. And then you will give your ID or your password. You're not going to give them, you'll leave them like that, and there will be a program that will fetch that, giving you a little menu. Or alternatively, you can hide it in a text file that you never have to print. So this little program will give you those two options. Either you put it in a text file so you don't have to enter it each time, but you don't never print that little bit of text that contains your details, or you get this little menu that pops up and asks you for the name and password, so you don't have to print it. So that's what we're doing there, specifying the URL, and that we only need to do once. Establishing the connection, and as I said, we do once. We establish the connection at the beginning, we close the connection at the end. We handle whatever we want in the program. We don't have to keep re-establishing the connection. So once we have done that, the next thing that we're going to do is we need to declare a variable which is going to hold our string, which has the statement. Well, before that, we want to declare a statement. So we declare something of type statement, which is one of the types that is given to us by this JDBC interface. And it's going to be, so the variable stmt, which is of type statement, is associated with a connection that we have created. So the connection is an object we created in the previous step. And we call a method called createStatement to create this object in the program. So now we have this thing called stmt of type statement, which can handle SQL statements. So we've allocated the resource to handle SQL statements. And we might want to have a statement, and we put it in a string variable. So I'm just defining my string variable SQL statement, and I'm putting in it the test of the statement I want to execute. In this case, it's select name from demo.m, where m by d is equal to 786. So if I was going to execute that in SQL, I'm selecting one individual column, the name, from the demo.m, which is the table that you use in the labs, and I'm asking it to return me for only one tuple. So what I'm going to get is one individual value, because it's one column, one tuple. Now, I haven't yet executed the statement. All I have done is I have put it the test string, but I haven't executed the statement. I need now to execute that statement against the database. And that is going to return me a result set. Whatever comes back from executing the statement against the database. And that is what my Java program then needs to handle. So, to execute the statement, I declare an object of type result set, which is going to handle the results. And I do that by calling execute query, a method, on the statement that I created earlier, the statement object that I created earlier. And I pass to it the query that I've just created as a string. So I'm passing the string query that will be then executed against the database server, and the results will be put back into this RS. So this is the actual execution of the SQL. And once that happens, I have this result set, which I have to manage in the program in some way. So I have now this result set could be one tuple, it could be more than one tuple, and I need to handle it in the program. So when I have a result set, what I have is a structure where I have a first line, a second line, a third line, because what I'm going to get is a record, a set of records from the database. It could be one individual tuple, or it could be a number of tuples. So the first thing that I do, this is a structure that I can navigate. And we're looking at the easiest possible form of navigation, which is going from one tuple to the next tuple to the next tuple. JDBC in these more advanced forms allows you to go backwards, to jump to a particular tuple, to do all sorts of wonderful things. We don't really care about that. All we're going to do here is when we get a result set, we're going to begin at the first tuple, and we're going to process them until we get to the end. And that's what we're going to do. So I begin by saying rs.next. Now, if there is something in the result set, then I am pointing to it now. Otherwise, that will return null, because there will be no result set to speak of. So it's going to return false after the last row, or if there is no row. But if there is one row, then it will point at that row. So I'm now ready to handle that row. So I can now extract the name from the first row, and in this case, I'm just going to print it to the program, to the calling environment. So I'm going to then define a string variable called the name, and I put the result of, from my result set, I use the method getString to get the name, and that then gets put into dname. So now I can print it. Now the parameters that I have correspond to the columns mentioned after the select. So we could say rs getString 1, meaning the first column that I mentioned in the select statement after the select. And you can get any SQL type as a string. So you can use getString to get everything. It's not always the most adequate form. So if I'm getting an integer, I might wish to use getInt. Although if I use getString, I will still get it, but I'll get it as a string, which might not be correct. Once I've done that, I want to do some tidy up, because I don't want to leave my resources open, because otherwise my server will eventually falter. So I want to call the close method on the result set, so I free all of the memory that is allocated to the result set. I close the statement, and I also close the connection. So that is the tidy up. And that is my program. I have gone, I have opened the database, I've accessed particular tuple, I've got it back, and I dealt with it. So that is the whole of that. Now, if I have errors in the program, it could be errors executing the SQL, they are going to be returned. And remember that I said if we leave the connections open, we are going to have problems. So what we really should do is to always have this finally. Now, in Java, if you have this finally clause, it is always going to be executed, no matter how the program terminates. So you can guarantee, therefore, that the tidy up will always happen. So what you should have in your code is a finally clause that has all of the tidy up code in it, because that will always execute even if the program ends in error. So then I have if rs is not equal to null, then close rs, and then I catch any exceptions that occur. If a statement is not equal to null, then I close the statement, and then I catch the exceptions. And if the connection is not null, I close the connection and catch any exceptions. So that is a final close, which is going to allow me to tidy up no matter what happens to the program execution. So that is going to be your cleanup code. So that really is all of what we saw there. We have a program. We might have to import data source. Is what the little program that hides your password. So we import it so that we can use it within there. Then I am going to begin my program. I'm going to declare things like my connection, my statement, and my result set. And then the first part there is going to load the driver. The second part there is going to establish the connection. Once we have done, we create a statement associated with that connection. Then we set the SQL statement. We execute the statement. We go to the first row. We display whatever has come back from the result set, which we have put into this variable. And then we tidy up, and we catch any exceptions. And we also have this finally group of statements to clean up. Even if we finish in any form of error, we are guaranteed that that will execute. So that is the first program. And if I was to, when you come to do this, you will do this using NetBeans. So you will have something like this. So if I look at my program, which is there, and I am to run the file, what you have there is that it has executed, so it's actually opened the connection, in this case to my local database where I have the same tables, and it's going to retrieve whatever this SQL statement is asked it to retrieve. In this case, I was trying to retrieve the name for a particular employee ID, so it returns the name is Parsons Carol. So that is executed the code as I had it there. Do we have any questions on that? Or is that quite clear to you? You never know with Java. Some people find it so easy. They say, oh, this lecture is really boring because it's too easy. Some people find it so difficult. They think, oh, I can't understand any of it, even if you break it down into small pieces. So I have to play this happy medium between explaining it to you in detail. I mean, I have to assume that most of you might struggle with this, but if you know, then hopefully it will become just like a piece of cake for you. So let's go then to the next example, which is going to handle, it's going to do exactly the same, but this time, instead of a single one item, I want to return an entire row. And I want to understand how I handle an entire row, because I've only seen how to handle an individual. So the first one did a single tone select. Now we're going to look at what happens if we have different data types that we want to get. Instead of just strings, we want to get different things. So some of the program is going to be exactly the same, because we're doing exactly the same thing. The connection bit is going to be exactly the same, because we always do the same. The driver, establishing the connection is going to be the same. And the end bit, closing the connection, tidying up, is always going to be the same as well. What changes is the processing that we're going to do. So this time, I still want to, assuming that I've done all that I did before in the other program, now I declare again the statement resource associated with my connection, because I've already established my connection as I did in the previous program. And now what I want to do is retrieve 3 columns. So I'm going to retrieve columns that have a varchar type, an integer type, and a decimal type. So again, I have my string, which is a variable where I'm going to put my SQL statement. And what I want to execute as my SQL statement is select name, manager ID, and hourly rate. So I'm now choosing 3 different things from the demo.env. Note that I can concatenate if I want to break down my string because it's too long, I can just concatenate it with a plus sign. So that's just concatenated one bit of the select with the other to make it more readable. That's all. So from demo.m, where m_id is equal to 786. So that's what I've done. And now I execute that. And in executing that, what I'm getting is, again, I'm getting a result set that I have to handle back in the calling environment. But this time, my result set is going to have 3 values. Because I'm still selecting only one row, but this time I'm selecting 3 values. So I've got to handle that in the calling environment. So I go back to handling my result set, so I have to move to the first line of my result set, if it is not null. So I do rs.next. Now I'm looking at the first line of my result set. And I'm going to extract the columns into the appropriate Java data types. So the first one is a name. So I'm going to put it into a string and get it as a string. So I declare a string variable, the name, equal to rs.getString. So I use this method getString to access the string that I want to handle within my program. And that is the name. So I could say parameter 1, or I can have name to associate that with the name that I ask for in my select statement. Then I declare an integer variable, the manager ID, and I am going to put the value there using the getInt method. Because if I want to get an integer, it's better to use getInt. And I want to put into that the manager ID, which is the second column, or I could have 2. It's the second column I ask of in my select statement. And then finally, I declare a variable of type big decimal, which is defined in the maths.h interface. And I have the hourly rate is equal to rs.getBigDecimal. So that is a get method for that type of data. And I put in it hourly rate. So those 3 methods are going to get the different data types and put them in the variables as I ask for of them. Now, if we look at how the get methods work, these are all the get methods that you might have in the JDBC interface, and those are the type at the top, the type of attributes that you get defined in a database management system. And the little x says you can use that type, that get method to get that particular type. The big X tells you this is the best get method to use for this particular data type. So for example, if I could look at get byte, that I should really use for something that is of type tiny int, although I could also use it for all of the others, including an up to long bar chart. It will still get that, but it might not be the correct thing to use. If I look at get integer, then I want to use that, for example, this is the third row, for integers, but it might also work for all of the other types where there is a little x. It's not the exact right get method to use, but it will work. And if I look at get string, it works for the majority of them, as I said, but it's better really for booleans and chars, for chars and bar chars is the best method. So that gives you an idea of what get methods you should use, depending on the type of data that you are going to access at the database end. Now, we have said that these result sets that we have, that we're trying to handle, are connected data structures. Because I've said you have a row, you have a next row, and the next row, so they are connected. I can go from one to the next, to the next, to the next. So the idea of the current row is maintained by the system. So if I say next, I'm in the first row. If I say next again, I'm in the second row. The system is maintaining the row I'm handling at the time. And so therefore, the result set methods are going to operate with this idea of this cursor. If you close the connection to the database, then you invalidate the result set. So you cannot continue to process the result set once you close the connection. So you need to process the result set before you close the connection. You cannot close the connection and then expect to carry on dealing with the result set, because it becomes invalid because it is associated with a connection. So you don't close the connection until you finish handling the result set. When we look at JDBC 1, there was only forward access. So you started with row 1, then you went to row 2, then you went to row 3, which is what we're going to use. As you go to JDBC 2 and further, they've introduced more sophisticated ways of navigating your result sets, but we're not really going to look at them, but they exist. So you could go to the third row, or you could go backwards, etc. So there are more sophisticated ways of handling the result sets. Now, in terms of how transactions work, by default, the JDBC is going to commit each statement to the database automatically. So if you work in a system which has auto-commit, you might want to turn it on, off, on or off. If you turn it off, then you can begin to handle transactions in the way that you wish. So if you want to turn it off, you can call a method called setAutoCommit to false, and then you can commit any transactions by associating with the connection the method commit, or you could roll back. .rollback will allow you to roll back a transaction. So if you have any exceptions that make you want to roll back the transaction, you can call on.rollback. And Java null, as I always say, nulls are difficult, is not the same as the null that you get in the database environment. So if you are querying a record set for a value, for example, if you do get a string name, if you want to test whether that name is null, then you should do if rs was null. So you need to call this method to check for a null value being returned. And then if it's null, that method will return true. Whatever getX method you use, you can use this if was null. And this is just a note about the UEA passwords again. We don't want you, the whole point is to establish a connection. You do have to give a name, you do have to give a password. If you put that in your code, and you print your code, and you leave your code lying around, or somebody looks at your code, they will see your name and your password. You're not safe. So for that reason, you will use this little program which will hide it. One way of hiding it is putting it in a text file that you never print. That means that when you run your program and you're testing, you don't have to each time enter the name and the password, which can be a bit tedious if you're doing a lot of testing. The whole point is obviously be careful where you close that text file, because it has your details in it. You don't want it accessible to other people. Or you can have it in a way that it actually asks you, as you run the program, for your username and password. The pop-up menu comes up, then you enter it, and then that gives you the connection. So you will get instructions on how to access that program in the labs. So let's now look at the last case, which is where we have more than one row. Because so far we've looked at programs that return only one row. But of course we might have more than one row, and then we're going to have to look through the result set in order to see what is there. So we're in the same scenario. We're still going to do the same as we did before. We have to, first of all, load the driver, establish the connection, set up the required resources, and so on, as we do for every of these programs. But this time, we are going to create a statement object associated with the connection we have established, and we are going to now have a string that selects empid name from demo.m ordered by empid. So in this case, this is not just going to return one row, this is going to return a number of rows, because my SQL statement doesn't have a where clause, so it's going to return all of the employees that are in the table. So I need to be able to handle them in the calling environment. So again, I have an integer variable, I have a string variable, and then I call my result set. I associate my result set object with the statement.executeQuery method, which is going to execute that query that I've just written against the database and put the result set in rs. Once I have done that, now because I have a real connected structure with more than one row, I have to navigate through it. So I need to do it using something like a while loop. So I can say while rs next, because that is going to return true where there is a row, but it will become false when I hit the end of my result set. So that is going to allow me to navigate to the first, and then the second, and then the third, until I finish. And what I'm going to do there then is for each of the rows, I'm going to select the empid using the getInt method, the name using the getString method, and I am going to output them to the calling environment, and then I'll do it for the next one, and then I'll do it for the next one, and so on. So if I run that program, which is doing a number of what you see there, if I can get to it, is that we no longer have just one name. It has printed one name after the other after the other. So for each of them, I have the number and the name, because this is what has been returned by my query. So I am no longer just handling one row, I'm handling all of the rows that I need to, and then I can process them within my Java as I wish. In this case, I just display them, but I could do something else with them. Are we all happy with that? All happy so far? This is a piece of cake. Easy. I can just go quickly, and then you can go and sunbathe in the sun, because it's a nice day out there. Why is it that when it's my lectures, it's always a nice day, and I have to do 4 hours on a straight? It's not fair. Thankfully, next week will be my last week, so I shall be sunbathing in the square while you sit here studying. So, I'm making you feel bad now, aren't I? Okay, so the last time we were using a while loop to go through a number of statements. So what we did was to look at how we did this and return a number of select statements, a number of tuples. What if what we want to do was insert or update a particular tuple? Because at the moment we have looked at how do we access data from selection, but not how we do things like inserting or updating the data, which is also things we might want to do in SQL from our program. So if we're going to do that, well, the program is going to do exactly the same. We still got to establish the connection and do everything else as we did before. We still have a statement associated with the connection, and then we define our string. So what we want to do now is insert into a particular table. This is a copy that I might have made of my original M table. The values, and this is just the string concatenation, and I want to insert 1, 2, 3, 4, other, and programmer 5663. So I'm going to execute the insert statement. But it's pretty much the same. The only difference is if I execute an insert or an update statement, what is returned is not a result set, it's an integer telling me how many rows have been affected by this particular statement. So what I'm going to have returned from that is an integer value, which is going to tell me how many rows were inserted, how many rows were updated. So I'm going to call it row count, declare it as an integer. And the way to call that statement is through execute update instead of execute query. Up until now we have used execute query, which returns a result set. If we want to do an update or an insert, we use the method execute update, which returns an integer. And I pass it the SQL statement, and if this worked correctly, then I should have only updated one row. So if row count is equal to 1, I could say, it inserted correctly, because I expect row count to be 1, because I've only updated one thing. If I did more, I'll expect more. The same if I had an update. If I want to do an update, again, something like the SQL statement being updated as I said, set hourly rate equal to 99. Then I want to use the execute update method, and it's going to return an integer, which is going to tell me how many rows have been updated. And I could then output to the environment the row count, which will tell me how many rows have been updated by that statement. Are we all happy with that? Good. So when you go to the labs, you learn how to run one of these in NetBeans. Some of the things that you're going to have to do is, for these things to work, you're going to have to add some files, jar files, so that they can run. One of them will be the PostgreSQL driver. You need to register that in the program, in NetBeans, so that the program has access to it. The other thing you will have to load will be the little program that hides your password details. So there will be details of how you do that in the lab, but basically what you have to do, if you are in NetBeans, is, so if I am here in NetBeans and this is my package, here in the libraries you will see I have loaded PostgreSQL jar file, and I have new data source jar file. That is the one that actually hides my passwords. So you have to go and add the adequate jar file to make sure that your program knows where the driver is, but also where that program is. Then you can execute your programs, otherwise it will complain. So you will get details of what and where the files are to load in your package. So normally you just go through something that says add there is something there that says add jar folder, and that's how you locate the folder that you need to add. Once it's there, you can then run your program without a problem.